Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill and this is my shop, and I have a little weekly update for you on a cool project that I made. Before I show that to you, I do want to say thank you to my high-tech graphics. If you follow the channel, you know I'm not much on that, but thanks to Paul at the Knackler's Workshop. If you like the stuff that I create, the content I create, you might want to look over there at Paul's the Knackler's Workshop, because he has some very cool stuff and he's always updating, and some small machinery. He just acquired a pillar tool which is very similar to my universal pillar tool that we built. So thank you again, Paul. He gave me a nice shout out on his channel this morning, so I wanted to return the favor. Also, welcome to all the new subscribers, and including my friend Larry. I had lunch with him this week and told him about it. He's not into metalworking, but he was just interested in general about what we do. And the machining hobby on the internet, especially on YouTube, is really cool. I've talked about this before. Larry and others, the hobby that I'm into with the locomotive is called live steam outdoor railroading, and there's actually a magazine for it. So that, to me, that proves it's a legit hobby. So anyway, this week, if you'll stay tuned with me, the next, I don't know, I haven't put the segments together yet, but I'm thinking probably 20 minutes to a half an hour, like I try to keep it. I made a very cool little simplified grinding spindle. It's not 100% complete yet because I need to mount the motor. I've made preparations for mounting a sewing machine motor on top here, about where my hand is. So similar to my universal pillar tool, I'm really happy with how the use of the sewing machine motor worked. I appreciate the encouragement. For those of you that remember, it was a little motor that I picked up at a yard sale probably 10 years ago for $5. It had these gnarly wires coming out of it, and I took it all apart. I thought it was burned out. I was really worried about it, but I took it all apart, soldered in some new wires, and it works like a champ now. It's great. So I found one on eBay that's a little bit more expensive, but still a pretty good deal, and I look forward to mounting that on here. So in the video, we talk about the idea that I have for mounting it, but it's got the spindle. This is the important part, the business end, as they say. I made this to fit the Sherline WW, or watchmaker, collets. So they fit in here in the nose, and there's a drawbar here that I just Loctited the knob onto the drawbar, but it'll fit inside the spindle here, and it'll be able to draw those up tight. So I'll be able to use WW collets, and the ones from Sherline range in size from 1/16 of an inch to 5/16. So I'll be able to hold all sorts of miniature end mills, grinding stuff in these collets, and be able to do some light duty milling on the lathe with this very cool spindle. It uses the sealed bearings that Russ gave me and I used for the drilling spindle, and but other than that, it's made a lot like the corn. And thanks again to the subscriber that told me about the Joe Pye method for drilling a straight deep hole. It worked like a champ. So thanks again for that, everybody. I'll do a little show and tell update once I get the motor, but like I said, stay tuned with me. And if you're interested in how I built the spindle, the pulley, and all the stuff that goes with it. So thanks again, everybody. Welcome to the new subscribers. As always, if you have a question, just ask. I'll do my best to try to answer. I'm just an amateur like a lot of you are. And if you have a comment, please leave it. I'm always interested to hear what other people say. I like to learn from other folks' comments. And if you don't feel like commenting or asking a question, but you enjoy the content, please give me a thumbs up. Please consider subscribing. Please pass the word, because I'm trying to grow the channel. So thanks again, everybody. Hope you have a great week. We appreciate you being here. Take care. I've started on the spindle for the grinding and milling spindle for the lathe, and this is the nose piece. Let me just show you the setup here. There's the bearing that will be inside the housing, and here is the nose piece, and I've faced it. Let's see, it's a kind of a snug fit. I'm going to green Loctite this on here, and this spacer corresponds with the size of the inner bearing race there. So there will be a nut on the back that will hold it all together, and these things, this will take care of the space for the front. And what I'm about to do, excuse me, is I'm going to flip the spindle end for end, and I'm going to use the modified version of Joe Pye's method for drilling deep holes. Spindle is almost 6 inches long, so I'm going to go in about 3 inches from the back, bit by bit, using his method. And when that's done, also I need to thread the back and to file it down a little bit so the bearing will fit. It's a little bit too tight of a fit on the spindle as it stands now. So I'll flip it around, prepare the rear end of it, and then drill, Joe Pye method, drill a little bit more than halfway. Then I can flip this around and drill through, then green Loctite this on and cut the 20-degree angle so that it'll match the WW collets. I'll show that as we go along. Okay, I've got the back side in here, and I just threaded the back 1/2 inch 20 so I can use this nut to hold the pulley on. I made a mark where the bearing goes, and I filed that down so the bearing will fit on there. So we're looking good here. Not much else to do except for start the drilling. I'm going to tuck the shaft in a little bit so it's better supported. Okay, this isn't really the authorized Joe Pye method, but it's basically using his idea. So I drilled in with the stubby. About 225 thousandths. This is an undersized. The hole I'm making is 5/16. So here's my little stubby, and that's undersized. So I've used the 5/16 inch reamer to make hopefully a perfect 5/16 inch hole. Now I can use the stubby again and just keep repeating this process, going in about 1/4 of an inch or so, and using the reamer to open it back up again. And then when I finally get to the long distance, or when I run out of capacity with the stubby, then I can get to the middle of the part with the full-size jobber drill. Okay, before I get around to the next machining operation, here's the finished spindle with the tail machined. It's bored all the way through, 5/16 of an inch. It's 1/2 inch. You can see I made these little marks here for where the bearings go, and I've got the snout Loctited on, and that has that bearing surface there. Then I set up, I used the 5/16 inch 5C collet, and I've got my little interrapid half-thou indicator in there to set the 20-degree angle for the boring for the receptacle on the snout of the spindle. What's interesting, what I wanted to point out, the flat section on these Sherline collets is only about 3/16 of an inch. So that's the part I'm indicating, and I've got it within about 1/2 thou with within 1 tick on the gauge there, and it's about as good as I can possibly get it. And what's weird is you can chase this all day long, and then you go to tighten up. If you're not careful when you tighten up the nuts, you can set it way out of whack. So you kind of have to hold this part down while you tighten the nuts up. So now I'm all set up, and I'll be able to bore the spindle out for the WW collets. Here we are, about halfway through machining the space for the collet. Just a few turns, and it's like I said, halfway done. So I'll show you. I'm working at 330 RPM or 360, whatever it is. Yeah, 360. And let's see. I'll just show you a few passes. With the boring bar like this, the spring, don't forget that you need to take spring passes, especially if you're trying to get to an exact number. This is the same, excuse me, the same boring bar I used before, where the back part of it is cut off so it doesn't interfere with the other half. So to increase the cut, I'm just dialing back here, go back about 20 thou on the DRO, it's only about 10 thou on the machine. Try to feed evenly here and hold the camera with one hand, so that's why it's not the most perfect even feed. It's really a simple process though. You can get this done in way less time than it takes to set up the whole thing. already know we're shooting for a 1/2 inch total opening, which is the size of the spindle. Let's see. Look at my hand being in the way of the light. Move this back out a little. Yep, it's getting there. Sorry, I lost you. Here we go. Alright. I'll keep going until we finish it. Alright, so here I've made the finished cuts. Got the nose of it opened up. I ran some Scotch-Brite on it just to clean it up. And here's the fit. Really happy with how that fits. That's going to be beautiful. So I'll make a drawbar just like I have for the corn. One thing I'm going to do before I take this out of the spindle out of the lathe is to run a 1 thou oversized 5/16 inch reamer through the center, just because sometimes when you machine the cone you make a little burr in there, so I just want to clean that out. But the overall the Joe Pye method, the modified Joe Pye method, worked great. So there's a good view of the 275 by 40 tap for the WW collets. As you can see, there's got at least a 1/4 inch of lead in, so you want to make your holes a little deeper than that. And also I'm using my favorite tapping solution, the tap paste, and I'm going to start this, probably do most of it or all of it by hand excuse me, by hand, just taking it easy because it's an import tap. I only have one of them. They're hard to find and they're not cheap. So I mean, it's been good quality. I don't mean to give you the wrong impression, but I had to mail order it off eBay, and it came from China, and it was something like, it was either $17 or $23, I forget. I mean, it was not cheap, but it's been good. I've used it on a few things so far. This is I guess the second drawbar, but as you can see, I'm just gently feeding it in by hand, and I'll back it up, reverse it, and go full depth in a little while. But this is my homemade tailstock die and tap holder. If y'all are interested in that, I haven't ever done a special on that. I got the plans off the internet, built it myself. So if you're interested in this stuff, please let me know in the comments. I can do a little segment on these things. Yeah, I turned the camera flashlight on for this one. I don't know if that's worse or not, but you couldn't see the threads really in the initial. Maybe you can see them there, but they came out really nice. So, whoa, dang it. I was going to do a test fit, show you this is the first WW collet I've tried on this drawbar. So there you go. Fits nice, and it seats all the way deeply in there. So really happy about how that came out. Just need to smooth the drawbar down on the whole length of it. It's about 5.5 inches long in this case. I made it just long enough so that there'll be plenty of space on the back end of it to clamp it down to the pulley. Here I'm drilling out the drawbar for my lathe grinding spindle. This is a letter F drill. I've got a tap I got off of eBay, which is the .275 by 40. We go in about 600 or about 700 thousandths deep, I think, so I can get the tap plane into work. While the Sherline WW collets are standard, the ones I made with my grinding stones are not. So here I'm counting 0, 1, 2, 3, 4, 5. Let's go ahead and one more. Pulling out the drill. You might notice I'm going faster than I normally drill. Bit more than 600 thou. The reason is it's not a bottoming tap that I'm using, so there's about a 1/4 inch of the tap, which is the essentially started threads. I'll show you that. Here we are in the middle of making the pulley that will go on the back of the spindle. 1 3/4 aluminum, and what I've done is turned a little nub there that is 5/8 of an inch in diameter by 1/8 inch long. This will be pressing against the inner race of the rear bearing, and this section here is 400 thousandths of an inch wide, and this section I just cleared out is about 200 thou cleared out. I'm going to cut it off with 100 thou, and it'll be a little bearing surface, essentially about 100 thousandths of an inch thick. That will be a bearing surface for the rear, the bronze nut that's going to go on the back. So the inside diameter, this is 1 3/8 on the outside. The inside diameter is 1 1/8, and I just used an ordinary cutoff tool to get us that close. Here it is. I'll show you. And now I've got my little form tools that I'll switch around. I'll use this one first to cut this angle, then I'll flip it over as I've shown in past videos and cut the other angle. I'll show you a few seconds. And so here we go, cutting the angle. As I've shown on these videos before, using a form tool you got to kind of ease into it. So I'll ease into the left side here, watch the depth, clean it off, retract it, clean off the stuff. I'm looking at what kind of a pattern I'm getting. There we go. So I just kind of lather, rinse, repeat until I have the one side done, then I'll flip it over and do the other side. Show you one more cut. This is a ton of fun. I really like it. It's sort of a artistic, I guess, design we come up with. You can see the little cone forming inside there. And this is the size. I'm planning on using the polyurethane round belting like I've used on the pillar tool and the form. Okay, so here we go. The form tools make quick work of the pulley. 1/2 is done. Now I just flip the tool over and I'll cut the other half. I did run the file on the edges just to kind of relieve and cut up, take off any sharp edges there. Here's the other side. So I flipped the form tool over. You can see the little cutter. You want to have the flat part parallel with your work, and you're ready to go. Plunging it in so it's making a small cut, watching the progress. Really good idea to stop and pull the chips away. These are just aluminum tinsel basically. If it was steel I would use pliers. A little coolant, cutting fluid, using the form tool back in again. We'll just continue on until we have a perfectly shaped half over here. Pull it out, cut it off, get the chips cleared out of the way. And here's the finished pulley. This is the side that will go against the bearing, so you really won't see that. And that's the side that will go against the washer. The only thing I need to do to it now is to deburr it a little bit and to file in a slot for an 1/8 inch keyway, because I figured I like putting keyways in spindles and stuff. It's just neater and cleaner and more effective than a set screw. Okay, here we are milling the 1/8 inch keyway slot in. Taking it nice and easy. I'm taking really small, shallow cuts because it's an 1/8 inch 2-flute end mill and it's solid carbide, and if you've used these you know exactly what I'm about to say next. Sorry about the erratic camera work. I was trying to focus on what I'm doing. But these carbide end mills, solid carbide, they cut great, they hold an edge forever, but they are brittle, so you don't want to jam them and break them. Alright, so there we go. Make sure I'm all the way back. Pull it up, cut the mill off. There's the keyway that I cut for it, or the key, rather. I took an ordinary one and shortened it. You see how it fits. I'm going to have to file it down a little bit, but that's going to be good. Sorry. I'll tap that into place and we'll be good there. Hey folks, as we wrap up this week's episode, I wanted to show the finished spindle with the keyway slot in there. There's the 1/8 inch key here, square key that I cut to size, the pulley which I finished last night, and then the little brass hex nut which is threaded 1/2 inch 20 on the inside. I made two when I made the corn spindle. I'm not sure why I did that, but I'm glad I did. So there, and that will be instrumental in keeping everything together. I'll do a segment in a minute here to show the whole assembly. I'll just be quiet and do the assembly. But today I made this little bar here, which looks very similar to the mounting bar that will will hold the spindle grinder in the tool holder. This mounting bar, this bar will hold the motor in place. So it's a 1/2 inch square steel, and I made that little trough in it to clear the nuts that will hold the motor to a piece of aluminum angle here. What I've decided to do, I like the sewing machine motor on the pillar tool, so I found an American made sewing machine motor for $9, but the shipping makes it $20 on eBay today. But it looked like it's in good condition, and the guy said that the seller said it was, and it was a reputable seller. So my idea is to mount the sewing machine motor on top of this aluminum angle. Haven't prepared this yet, other than cutting a short section of it, but I'll drill through and be able to screw the angle to the motor. Then I can set that on top here, and as you can see, I've drilled and tapped a couple of 1032 holes that go all the way through here. So whenever I get this into place, with the motor in place, with the belt and everything lined up, then I can mark and drill the holes, and I can just do clearance holes and then tighten up the assembly together. So it'll be a nice compact little assembly mounting the motor. Pretty excited about that. I won't get the motor until next week, so I can't finish that today, and I'm not going to hold up this week's video of that. So I'm going to shut the camera down, get all ready to do the assembly here, and put the thing together as far as I can get it, so you can see all the pieces, and then that'll be the last segment for the week, and we'll wrap up and move on to something else. Thanks again, everybody. Stay tuned for the assembly. Alright, here we go with the assembly. Tighten up the motor mounting rail. It's looking good. And I slipped the bearing, the front bearing, over that. It's a tight fit. I mean, a snug fit. It's just like how it's supposed to be. So this will be the front section. Sits in there okay. Back section. This is going to be interesting. With the bearing needs to come. And then the set screw. I may actually have to shorten the dang. I'm going to have to tap that in. I might have to shorten the little arbor. Hang on, let me get a tapping thing. Okay. Man, I really had to smack that rear bearing in, but it's nice, tightly seated now. And I did have to trim a little bit off this 1/8 inch keyway, piece of keyway. So it fits there good. Let's slide on the, which is which? Okay, the small side is the bearing side. Slide the pulley on, yay, that went well. And just add the nut. Put the smooth side facing outwards here. Nice. Alright, well, I'm not going to tighten this all up now, but really stoked about how this is going to be. So we can have the thing held here, the little sewing machine motor. I'll have to run wires, obviously, And then this will be the little bracket that holds the motor to the grinder. And if you can visualize, let's pretend this is the motor. So the motor and the little spindle here, just lining up with that pulley, should be in good shape. Alright. Oh yeah, here's the actual spindle itself, the 5C, the Sherline WW collet. Sorry, I'm getting my nomenclature all goofed up, but the collet goes in here, and we can tighten. Oh, I know, I need to make the knob. Shoot. There we go. I need to make a knob for the spindle. Okay, here it is with everything put together with the little WW collet inside. The drawbar is just gently snugged up there, and I need to make I'm going to make an aluminum knob out of the same material that I used for the pulley, and make it the same diameter. That'll help protect the pulley a little bit. Of course, the pulley's smaller diameter than the grinding spindle itself, so just put the make a simple step one with a nice bearing surface here that so it can snug up, and then a little knurl pattern on the outside just to make it easy to hold. I'll bring you back and show you what that looks like. It's always fun to capture the magic of knurling. I'm going to tighten this up a little bit. I'll show you the finished product, the knurled knob. Knurling's just about complete. Tightened it up a few more times. Let me stop the thing and show you the pattern that it looks pretty good. Time to finish it up. Here's the finished hand wheel for the drawbar. Just that 1 3/8" aluminum. I've drilled it and then reamed it for the 5/16" drawbar. I just cleaned it off. Got rid of most of the cutting oils with ordinary nail polish remover, and just because I have it, basically I'm going to use some of this Loctite primer stuff. Got this from a seller on eBay eons ago. I think it's probably a lot like the acetone stuff. So we'll let that dry a minute, wipe it off with a clean cloth, and then we'll apply the Loctite 680 green Loctite, which will secure it on there for good. And here's the application. This stuff works in an anaerobic manner, so as long as it's got air to it, it doesn't harden, thankfully. But inside here will be anaerobic, so I just slip it on, twist it around so the green Loctite gets all around, and I'm going to set this here to dry overnight, and we'll be good to go.